This is a numerical problem. So yeah. So if it is not clear and the screen not visible, you can tell me directly, so that otherwise you don't send the message, because I can hear your voice. Okay.
Sir, it's
So
because of
now
network
the question
problem,
is
sir.
that, yeah, because of network problem. So I will just repeat this, so that it will be completed. Okay, no problem. I will just repeat that. So the question is that the speed of 1 horsepower, 230 volt, 500 rpm. Yes, please tell.
No, sir, continue, sir.
500 rpm, 4.1 ampere. Okay. 4.1 ampere separate axle DC motor has RA is driven with armature supplied from class A chopper and a 240 volt DC source. So from the first statement, what he is saying is that there is a motor in there whose ratings are 1 horsepower. So 1 horsepower in the sense 746 watt. Its output power is 746 watt, 230 volts. Okay, the armature voltage, the voltage going to the armature is 230 volts, and its rated speed is 500 rpm. Its rated current is 4.1 ampere. These are the ratings of separately excited DC motor. It has armature resistance and armature inductance as these values. Okay, driven with from a class A chopper. So class A chopper is first quadrant chopper that I have explained in the last class. From a source of how much? 240 volt DC source. Okay, so from this first statement, I would like to draw the circuit diagram from the first statement itself. So this is the circuit diagram. Okay, this is the circuit diagram. So in this circuit diagram, this RA, LA, EB, this is the motor. Okay, whereas this is the chopper. So this is the chopper circuit diagram, which 240 volts he has given in the data. RA value, LA value he has given. EB is the back EMF. E naught is the output voltage of the chopper. This output voltage is going to the armature of the separate excited DC motor. From the first statement, this is the data. This is the circuit diagram. Then what is the second statement? The field current is at value that gives rated operation on 230 volts. So see 230 volts in the sense the rated voltage. At the rated voltage, okay, you keep the field current constant, and the chopping frequency is kept constant at 50 Hz. What is the chopping frequency here? You have the switch is there. The switch is there. Switch on off is there. So it has some frequency. That frequency is 50 Hz. So if you know the frequency, what is the advantage is that you can easily find out the time period. Time period can be find out from 1 by f. Okay, we got it. So the second statement also we understood. Now the third statement is said that the minimum load torque is 5 Newton meter. This is the third statement. Okay, so the load torque is 5 Newton meter. Where is the load torque? You will find out. I will just write here. I will just write here. Yeah, this is the actual circuit diagram. In this, we have the load torque. Now, this load torque value, how much he said he is saying 5 Newton meter. He's saying 5 Newton meter. Okay. So this is 5 Newton meter. This is 5 Newton meter. And what is this here? Okay, so which question is lower? So first question is that what is the question is asking? What is T on? He's asking what is T on? When at 500 rpm and at 5 millimeter load torque. At these two values, he is asking what is T on. That is the question. So based on the question, we will start with this. First of all, where can we find out the equation which has T on? One equation we can find out. What is that? This is E naught is there. This is 240 volts is there. So this is the switch is there. So already we have derived the expression for the relationship between E naught and 240 volt. What is that? Alpha into 240. This, that is the chopper output voltage input voltage relationship. What is alpha? Alpha is the duty ratio. How can I write that? T on by T into 240. Yes. So this is the equation. So in this equation, you have T on T on is there, so this T on is there in this equation. So then what are the unknowns here? E naught is one unknown, T is another unknown. How can I find out T? T is equal to 1 by 50. That I know already. Okay, 50 hertz frequency is there. So T we know. Only thing what we don't know is that E naught we don't know. How can I find out E naught is that? E naught is the input to the motor. So we have one equation, input to the motor E naught is equal to EB plus IARA. See, we want to know what is E naught. To find out E naught, we are going for this equation. That's it, nothing else is there. So in this equation, what we know, what we don't know. RA value he has given in the problem as 7.56 ohm. Then EB value we have to find out. Then IA we have to find out. So if we find out these three, we can find out E naught, we'll substitute here. So to find out E naught, we need to know all the three. RA already we know. Then EB, how to find out EB? What is EB? EB is the back EMF. EB depends upon what? It depends upon the speed. Now, at which speed he's asking the question? He's asking at 500 RPM. So at 500 RPM he is asking. So EB also you have to find out 500 RPM. But if you see the data in the question, what is the data in the question? Then what is the rated speed he has given in the question? The rated speed is also 500 RPM. So the actual question is also at 500 RPM. Now the rated speed is also 500 RPM. Then what we do is now we will find out EB at this speed. The rated speed we will find out. How to find out at the rated speed? We use the same equation once again. What is the same equation here? EB equation. EB is equal to E naught minus IA RA. We will find out this. Okay. Now we will find out EB at the rated speed. Why at the rated speed? Because the question is also at the same speed he's asking. So its advantages we will find out at the rated speed. So at the rated speed, what is EB? What is the rated voltage E naught here? That is the input voltage to the motor. He has given in the rating as 230 volts. That he has given in the rating itself. Minus what is rated armature current? Rated armature current 4.1 he has given. What is RA value? 7.56 he has given. So we simply solve this, then we will get the value of EB. Then what is the answer we got here is 199 volt we got. So it means out of these three, RA we know, EB also we know. What is the only thing which we don't know? IA. IA we don't know. How to find out IA? If we find out IA, all the three we know, then we got E naught here, then we substitute E naught here in the TR equation. That's the logic. So at the end we have to find out now what is IA. Next question is what is IA? To find out IA, we have one equation. T is equal to K into IA. For the separate leg center motor, we will use this equation. T is equal to K into IA. To find out IA, we need to know what is K. We need to know what is T. How to find out K is that back EMF we find out EB. EB have one equation K into omega. One equation is there K into omega. So this K and this K both are same. So K is equal to EB by omega. What is omega? EB we find out 199. Omega is equal to 2 pi n. 2 pi n by 60. What is n value? N value is 500 RPM. Then K value, if you substitute that, what we get the K value is I think 3.8 we got. So K value we know. What is the only thing which we don't know? T we have to find out. Please remember which T it is electromagnetic torque. This equation is for the electromagnetic torque. So if you find out electromagnetic torque TE, if you find out electromagnetic TE, then we'll substitute electromagnetic TE, then we'll find out the value of IA. So the logic here is simple. We want to find out IA from this equation. To find out this equation, we need to know what is K, we need to know what is TE. K we find out from the back EMF equation. TE we have to find out. Okay, how to find out TE? We'll go back. We'll go back to this circuit diagram. Here you have TE, P6 now. Here you have TE. And here it is TL. Now what is the relationship between TE and TL? TE is equal to TL plus T losses. What are the T losses? T losses is nothing but torque because of rotation loss. T loss, but torque because of rotational loss. Torque because of the rotational loss. So it means to find out T loss, what we need to find out? We need to find out rotational loss. Once again. So in the question you have so many other questions are there. So in the question to find out, see here, very simple. I want to find out what is TE. Why I want to find out TE? Because to find out armature current, in this equation to find out armature current, I need to know what is TE. What is the equation we got in the TE? The equation that we got TE is that TE is equal to TL plus T loss. What is TL? In the problem he has given us 5 Newton meter. That he has given that. Only thing we have to find out T loss. What is T loss? T loss is nothing but torque because of the rotational loss. So we will find out what is the rotational loss. So power we will find out first. So how to find out rotational loss is that we have another equation. What is that another equation? Input power is equal to output power plus losses. Okay, what is the input power? The input power in the sense, see, he's asking at 500 rpm. So rated speed he's asking. So we'll find out the input power at the rated speed. What is the rated power? How do you find out? Rated voltage 230 volts into rated current. Yes, we'll find out like this because that he has given in the data itself. Output power. What is output power? In the data he has given that it is 1 horsepower. 1 horsepower. So output power of the motor is 1 horsepower. 1 horsepower in the sense how much it is 746 watt plus losses. What are the losses here? Copper loss plus rotational loss. These are the two losses he has mentioned in the problem. How do you find out the copper loss? Okay, so this. Then what is the only thing left? It is now rotation loss. We can easily find out because all the three we know rotation loss. So what is the answer you will get when you find out the rotation loss is 70 watt. You will get 70 watt if you solve this equation. So we find out the rotation loss now. What is the torque because of the rotation loss? How do you find out power divided by omega? What is power we got? Rotation loss we got 70 watt. Omega 2 pi into 50 into 500 over 60. We will find out. Then we will got the answer approximately 1.336 Newton meter. So we got it. So now we will go back to that equation. Which equation? Which equation? Yeah. TE is equal to TL plus T loss. What is TL? 5 Newton meter. What is T loss? We find out 1.336 or 337. Yeah, we got. So we got TE value. How much TE value we got? Why we want TE? Because we want to find out IA. That is the logic. So IA is equal TE by K. What is TE we got? TE is equal to 5 plus 1.337 divided by K. How much? 3.8. Then we will get approximately 1.667. So we got IA value. So at the end we got IA. Why we want IA? We'll go back to this equation. Which equation? This equation. In this equation, I told you your three unknowns are there. EB, RA, IA. EB value 199, RA 7.56, and IA just now we find out as 1.67. Then we got the answer for E naught. Once we got the answer for E naught, we substitute E naught here. Then we get the answer for T on. That's it. So that's the first question. First question is solved. Now, what is the second question he is asking is that, what is the second question is that, with this T on, is the current IA continuous or not? Continuous or not? How to find out this continuous or not? Is that you have an equation for IA maximum. Last class problem, we find out IA maximum, IA minimum. Please use those equations. Using those equations, what we do is that for continuous conduction, you see now, this is continuous conduction. So in the continuous conduction, the boundary IA minimum is this. IA minimum is equal to 0 at the boundary. So we have IA minimum equation, we substitute that equal to 0. Then in that equation, you have some T on. That T on you will get here. For the second part, I'm just giving you the hint so that you will solve yourself. You have the equation for IA minimum, you have the equation for IA maximum. In that equation, what we do is that you equate IA minimum 0. When you equate IA minimum 0, you will get the answer for T on. You can easily get the value of T on. So that T on you compare with the T on which you got in the part 1. First question we find out T on. So compare both the times. Then you will understand yourself whether it is continuous conduction or discontinuous conduction. So we get that answer. So you get the answer as continuous conduction. You check yourself. What is the part C is that at this value of T on which you got in the part B, he is asking you to find out load torque. How do you find out the load torque once again? So load torque, you have T is equal to PL plus T losses. So to find out PL, TE minus T loss. T loss we already find out that is a constant 70 watt divided by 2 pi 60. How much you got? 1.337. So this you know. This you know already. T loss you know. What is the only unknown? TE we need to find out. Then only we will get the answer for TL. How do we find out TE once again? To find out TE, what we require here? We at this T on, we will find out E naught. How do you find out E naught? E naught is equal to 240 into T on by T. So T on we got from the part B, that we substitute, then we get the value of T E naught. So from E naught, okay. So that is the input voltage we got. So TE is equal to this E naught. You multiply this E naught So you multiply this. So TE we have to find out here. So to find out TE, uh, what is the formula we will use here is that, yeah, we will use this formula. K into E. We will use this one. So K value we know already, that is 3.8. We have to find out IA now. How to find out IA is that we got E naught from this. Once we got E naught from this, there is one equation is there. E naught is equal to EB plus IA RA. EB value we know that is 199. EB value we know that is 199. RA value we know that is 7.56. Then we can find out IA from this directly. Okay, so because E naught we find out from this equation. TR we got from the part B. Then we got E naught. Then IA we will find out. Substitute IA here. Then we'll get TE. That's it. So we got TE, we got T naught. Then we get the answer for TN. That's it. This is how you solve the problem. Okay.